Hello, and welcome to Nokia's Technology Vision webinar. I'm Aaron Heller, lead writer for Nokia Bell Labs and the Strategy and Technology Organization. I'm very pleased that all of you from around the world can join us today as we dive into the future and explore the long-reaching trends that are shaping the technology of tomorrow. This is the first of what's going to be 5 webinars. Today will be an overview of our updated tech vision, in which we take a look at the big picture that's really reflecting everything we're doing here. And following that, we're going to have deep dives on AI, Web3, spatial computing, and quantum technologies. We're going to try to have a fireside chat type of conversation today, so we'll keep this as conversation as possible so that everyone can get a good sense of where we are going together as a company and as an industry. We're also going to have some supporting slides, you see, and we'll incorporate those throughout. But we'd like this to be as interactive as possible. So please, for all of our viewers, from wherever you are, use your Q&A function that you have on your screens and post any questions you have. And then we'll try our best to address as many as possible at the end of the session. Finally, we'll post a link in the chat with additional material to read about our entire technology vision. And also be sure to check out all the details of our tech vision on the Nokia dedicated webpage. It's on our Nokia website. It's got all the information we're going to be discussing in this call and much, much more. So without further ado, let's kick it off and first meet our panelists, Jone Soininen, Director of Technology Leadership, and Stefan Kind, our Senior Principal of Technology Vision. Welcome, gentlemen.
Thank you.
Hey, Aaron.
All right, so Jone, let's kick it off with you. Nokia Tech Vision, give us a bit of an intro into that. What is it? Why do we need it?
So the Nokia Technology Vision is something that where we try to show how we see as the leading technology vendor in telecommunication, what the world looks like in about 10 years. And this we do that we can show to our customers which direction the world is going, allowing them to be ready for the future, and also to have a dialogue in the industry as a whole about what are the technologies, how they move the world, what are the biggest trends, and how does that all impact our networks.
Yeah, well, this is something we've been doing for many years, and we update it annually. Stefan, we've been producing a version of this since 2021, but I see that this time it's more future looking, beyond 2030, even towards 2035. What else is new this time around?
Yeah, Aaron, you hit a good point there. It's the first thing really is to change the time perspective. As initially Technology Vision 2030 was seen to be a bit too short to midterm now and not a vision anymore. But opening up into the decade of the 2030s also means that we need to take a broader look into upcoming technologies, as well as in those technologies, in particular digital technologies, which are shaping and changing the evolution forward for the next 10 years. So we're looking a little bit into bigger technology themes and a broader scope compared to the year before. In the years before, we have been quite vocal on metaverse, and in particular the different type of metaverses, so the consumer metaverse, the industrial metaverse, and the enterprise metaverse. Now we broadened the scope a bit for the technology themes, and therefore also then we incorporated the 4 deep dive topics, as you mentioned, as we will also see them as part of the webinar series here.
Great. So metaverse out, we're going beyond that and bigger picture. Jone, let's pop over to you and jump into the future as Stefan talked right now. And we've heard all about the physical human digital fusion, how that's all going to work together, with AI being, of course, a big part of that. How will our world look like in 2035?
Yes, Aaron, the world in 2035, what we think that are important parts of that is 3 different things. We see these 3 different things as the physical world, the digital world, and the human world. There, the physical world is, of course, what we think is, it's basically everything physical, everything that you can touch and you think and you feel, and we're part of that as well. Then the digital world is anything that can be represented in ones and zeros. So basically anything that can be digitalized and anything that is digital. The human world is an interesting concept because it is basically that, what is part of our everything that what we stand for. It's our values, it's our ethics, it's our core things that what makes us human. And those things, then when we put them together, there comes the interesting part. And that is basically that the digital world represents everything that makes sense to digitalize of the physical world and the interactions between those, and that those are then governed by the human values and the human side of this world. So that altogether, these three things, where we see that the key glue between those is really artificial intelligence by 2035.
You mentioned the zeros and ones. Those are the bits that obviously were also developed by Claude Shannon here at Nokia Bell Labs, a part of our legacy over here. Also one of the pioneers of artificial intelligence. So we've got a lot of that in our podcast that we're doing about a bit of tech and our centennial here at Nokia Bell Labs. But that's in the past. We have 100 years of legacy here. Let's look at the future, and let's take a look now at the environment in which this technology is evolving, all these things that you mentioned right now. So let's just jump over to the macro trends. What are the big picture that we see here? I understand we've got 4 of them: geopolitics, climate, security, network monetization. Yone, why don't you take us through that and explain how these macro trends are impacting technology evolution?
Yes, Aaron. These macro trends, as you notice, they are not really technology trends, but how we see this, that these are trends that have potentially a tremendous impact on the technology trends as such, and especially on how technologies will be taken into use in the world. And if we look at the first one, which is the geopolitical trend, that is where we see that the world is becoming much more volatile, much more fragmented than it has been before. And there, what we think is important is that the role of trustworthy technology providers becomes much more important. And that the technology provider is somebody you can trust, that both in the terms of that they provide the technology in the right way, they are trustworthy in their technology, and they are somebody who can live through the turmoils of the world. The second one is the climate change. And that is, of course, something that has a lot of impact on our world as well. And as we've said as a company, we believe that there is no green without digital. So we see that the technology has a big impact on combating the climate change and the change and impacting the what comes out of the climate change. But what we've seen now as well is that there is also that the technology itself has to adapt to climate change. Climate change, there will be a change in the world, and the technologies need to take that into account. And that comes then to the third point, which is the rising security, defense, and resiliency needs. And when you look at the 2 first trends there, the secure, this means especially the geopolitical trend, there you see really that the importance of security is becoming more prominent. The resiliency of in a volatile world and in a world where we have more changes through the climate change, all those have an impact on the technologies itself. The fourth one, on the other hand, is a little bit different. So that is the network monetization. And when we look at the network monetization, this is much more than closer to our telecommunications industry. And what we see here is basically that the world, previously, what we did is what we built always a new network, and we could trust that there would be usage for that, and new customers would come, and so on. Now there is more of an interest of seeing that how do we deal with the monetization? How do we deal with the return of investments for our customers? And our customers are much more interested now already from the start to pay attention to that when looking at the new network technologies.
All right, well, there's a lot to cover over there, Stefan. Let's jump over to you about these macro trends. We did the what, now the why. Why are we looking into these specifically?
Yeah, Aaron, I think the key point here is that the macro trends, as Jonna just described them, very much shape the environment in which technology is evolving. So there are two main things there. The one thing is on how technology and how innovation has been driven. So where is the money basically put into? Because if there is research and technology evolution is very much based also on the funding in the respective areas. And there needs to be funding for developing those things, not only doing the research, but then also taking it forward into productization. As Jonna just mentioned, the economical aspects is quite an important one. And we see this economical changes as interest rates stay for longer than expected on a higher level, which means that if you at the same time have stagnating revenues, then obviously the need for monetization and clear ROI of new functionality becomes quite vital. So the one thing is really to say in which technologies we see a stronger momentum on how it's been developed over the next couple of years in order to materialize into the 2030s. And the other thing is also then where do we see technologies been adopted and what kind of market dynamics is behind that, as market adoption of technology is vital in terms of the success of technologies and the way how we use it.
And would we say that our vision overall is optimistic? Because we're talking about the volatility over there of all the changes that can happen and all the unpredictability in all these areas over here, geopolitics, climate change, security, and more. What's your feeling towards that 2035 range we're talking about?
Well, even though there is a lot of uncertainty, there is the good thing is that there are a lot of technological answers actually to deal with many of those. I mean, cyber threats on the one side you have, and security is a major concern. Also, resiliency for enterprises, for nation states, etc. But on the other side, we also see technology to help to mitigate the risks and challenges and to cope with those in order to get us to a safer environment. So it's a little bit of both, actually. That yes, there are more risk and more volatility potentially out there, but then on the other side, also technology helping to deal with those.
All right, so that's the macro trends, that's the big picture. Let's get into the more nitty-gritty of the technology trends themselves. We've got a bunch here, as you can see on our screen over there: device evolution, enablers, solution and service evolution. Stefan, why don't you walk us through those keys to technology trends that we've identified?
Yeah, and it's not just the three here. The three we see on the next slide where actually this is the higher layer, right? So this is more when talking about devices and enabling platforms and services and solutions. This is the layer which is closer to the user. And then later on, let's also talk about the lower layers like hardware and software technology, as this builds the foundation for those upper layers. So what we see there is, starting with the devices, for example, that there is a strong momentum actually towards multimodality. Basically, the evolution and the advancements we've seen with AI ML have significant impact actually on the device evolution. Natural language processing becomes a key component for any device interaction, what we see there, and enhancements in terms of voice interaction, gestures, etc. Will become integrated quite soon into all of the devices. On the other side, we also see that smartphones may stay longer than expected because they were probably not only used as a smartphone, but they are also a good combination of a processing unit with some battery capabilities, which can act as a local hub for connected smart devices around us.
So people are imagining that smartphones are going to go away or something like that, or that there's going to be something they're going to disappear?
Well, there was some notion in the market where people were thinking of is the successor of the smartphone the wearables or the glasses, and people will be only wearing glasses. Now, what we see is actually with the glass evolution and head-mount devices that in many cases they rely on the connectivity of the smartphone, they rely on the processing capability of the smartphone, and they rather go in conjunction, so they stay together and come as a companion towards the smartphone. At least that's the way how we currently see it, and what we've also deriving from some of the metaverse work and research we did in the past.
Now, what about medical engineering? There's a lot of advancement in that too.
Yeah, what we see there is that devices, and in particular the sensing piece, but also the other way with computer-brain interfaces, there is the potential actually for a closer integration of device types and enhancements towards sensing what we are doing, probably also not only the physical piece, but also sensing the emotional level of whatever the cognitive load of what we are doing, which then, as we talk later on about the services and solutions which enable then also services which are taking benefit of that. So if we can understand the emotional level and the cognitive level of people while they are doing something in a training scenario or so, this becomes quite vital and a real valuable asset for improving services in future. And on the other side, obviously, the growth of sensors overall is quite an important thing in order to understand our surroundings, our environments. And the key point there will be that they are low power and AI enabled or AI connected in order to make them more meaningful. Basically, we see that we have those devices and sensors to sense and contextualize the physical world and interwork with the digital world. And this is also why we talk about that the digital, the physical, and the human world are converging closer with the new technologies.
I'm going to hop over to Yona now, because in our updated tech vision, it says that there's the quote that I saw over there was, "The smart world ahead feels more human." Even with all this technology we're talking about, you say it feels more human. What do you mean by that?
Oh, that's a great question, Aaron. So, and this was something that we really thought about, that when we're looking at the new technology, and especially that what Stefan was talking about, that you have this interaction between devices, sensors, new kind of multimodality that you how you interact with devices. Plus, you have new enablers that allow you to interact with the world around you, like the spatial computing or spatial internet. What that is basically that though that you have a lot more technologies around you, it is made in a way that where you can interact with it in much more human way, in much more in a natural way than you're used to. So it's not anymore that, like you said, is there a notion about that smartphones going away? It's not only that you basically touch your screen and you read it, and that is the way that how you interact with your phone, but you have the things like glasses, you have the spoken word that you can interact, or gestures that you can interact with your technology, which is much more natural for us than just clicking or typing.
Well, this might be out of left field a bit, but I mean, it's sort of, and correct me if I'm wrong, but it's kind of connected a little bit to Industry 5.0, no? Like that the Industry 4.0 was really focused just on the technology, and the 5.0 has a much more human-centric element to it.
Yes, and that is basically that what we're seeing, that it will happen not only in the consumer space, but it will happen also in the enterprise space, and of course, like you say, it will happen in the industry space. So, and when you think about the possibilities there, that things that what you have interacted with previously in ways of buttons and things like that, which in the industrial space generate the possibility for error. Now we have new, more human ways of interacting with that, which also then improves productivity and safety as well.
So we mentioned at the beginning, we're going to have deep dives, obviously, on the themes afterwards with Web3 and spatial computing, and that sort of fits into something over here, right? You mentioned, I guess, 3D maps and digitizations, all these Web3 technologies. This fits into this whole area that you're discussing right now.
Yeah, basically the Web3 and the spatial computing are very much determining the way how we see the enabling layer to evolve, right? So it's kind of, with the spatial computing, you kind of make the world around you clickable. So the next level of the internet, so to say. And the Web3 actually, as a distributed layer of trust, builds the foundation for services and for trusted applications built into this world. So that's the key point there. And what is also comes along with that is that we need to think about how to build maps and map information in future. One of the key things what we see there is that there is a strong need, for example, for standardization of shared 3D maps to allow really people to participate in an open environment into that building of that new spatial environment. Which is quite important that there is not one single player trying to own that, but it's a distributed and shared medium where everyone participates to make it more powerful.
So, Stefan, let's take this up to the higher level of technology, the different sphere here. And we know that hardware and computing, they're the bedrocks of the advancements of the higher level of technology. But how does software and hardware, how do they together change the foundational technologies, and how do they help them evolve?
Yeah, let's start with the hardware piece and probably 4 areas which we see there as fundamental areas to evolve. The first one is that we see the end of Moore's law, or that we are getting closer to that. Well, basically, Moore's law is, as we all know, it's not a physical law, it's more an observation. And this means that if we don't see processing power going to grow in the same way as we've seen it in the past, we need to look into new means on coming back to Moore's law and the processing advancements, as the need for processing is still unbroken, right? Looking for just with AI, currently the demand in terms of data centers, in terms of processing capabilities for the training or for the inference of that, that's quite substantial. So we need to look into an understanding on how chip technology, how semiconductor technology is going to evolve. Things and evolutions, what we currently see there is from going from chip design into chiplets, advancing also with AI on building new chips in the design process and enhancing that. But on the other side, also looking into the material evolution. So how do we see like nanomaterials to advance in order to build chip structures of the future, and also how to take them forward, thinking of things like carbon nanotubes or 2D layered material, how to take them forward from a research stage into a productization stage so that they can become commercially available with a reasonable yield in production to make them economically also feasible. These are areas where also within Bell Labs, we have a lot of research activities ongoing, and also with our partners to look into on how to get to a stage where we kind of have the Moore's Law 2.0 or advancement in that made possible.
It's interesting that you mentioned those things. That when you talk about Bell Labs, it reminds me a lot of, I know we are talking about the Bell Labs centennial now that we're marking, that this is a lot of legacy of Bell Labs as well, with these materials and inventing the transistor and the silicon, all those things. Let's move on to quantum. Quantum is also something we have a long legacy, and that was quantum 1.0, the earlier version. Now we're in 2.0. How does that play in here?
So if we look at quantum here, and the thing is with quantum is that we feel is a technology that has great potential to create disruption in this time frame before 2035, and that is why we've used quantum as the theme of this year's technology vision as well. But when we look at quantum, we often talk about just quantum compute, but what we see is also important is also quantum communication, quantum sensing, and those together with quantum compute are those that create the potential for disruption. And these things are basically something that what we talked about previously about the uncertainty. It's difficult to say when exactly quantum will come and how it will disrupt the world, but we see that it can disrupt the world. So if we look at, for instance, quantum sensing as an example here, is that it's a topic in quantum that it isn't just about the quantum compute that what we've used to discuss about, but we're looking at that we can build sensors, for instance, timekeepers that fit in devices which allow much more precise timekeeping, which then allow other services like much more higher precision in location-based services and things like that.
Let's wrap up this slide over here with battery technology evolution. I don't think we addressed that yet. Stefan, do you want to take that one?
Yeah, sure. A key point is that all of these technologies are relying on electrical energy, right? And so in line with the evolution which we see there on the processing side, on the semiconductor side, we also always need to look into how battery technology is going to evolve in order to enable that, to have higher integration basically of energy into smaller volumes and still keep them stable, but on the other side also have the sustainable aspect of that incorporated. So how do we get rid of critical materials or critical minerals which currently we are relying on, and how to take material science forward in order to get us hopefully sustainable batteries with a very high energy density in future.
All right, let's move on from this to speaking of energy efficiency. Let's move on to network evolution, because what we've learned from these technology trends you just discussed right now is that there'll be a lot more digital services added over the next decade. So, Stefan, do we have a rough idea about what kind of traffic increase we're talking about here?
Yeah, Aaron, before going into the network evolution, probably we have a short look also into the software side of things, right? So we talked about the hardware dimensions, so let's probably address the software piece as well, because it's so important as a layer, and probably even though we say hardware is the bedrock of technology evolution, but software layer actually is the key layer in between. Just thinking of and looking for the 4 dimensions which we are building here, but picking up from the last one, as we just talked about the energy efficiency and the need for having energy efficient solutions there. Green software becomes quite an important, or has a potential to become quite an important topic. Just comparing and giving you a very simple example, comparing Python with C, for example. C and some of us are old enough to know what C and C++ is, and
also
there is
invented in Nokia Bell Labs.
Bell Labs legacy on that, exactly. But what we know and what investigations have shown is that we have round about 80 times, 90 times higher energy efficiency writing code in C versus if you write it in Python. I mean, obviously, for looking for the younger generation, most of them knows Python very well, and this is what they are grown up with. But what we need to understand also is that code needs to be written if the world becomes more digital, which means more is written into software. It becomes so important that we find energy efficient ways to deal with that, and not going back to C necessarily, but finding new languages which are more efficient, energy efficient than some of the existing ones. And then obviously other software technologies we also need to look into. Jonna was mentioning in the macro trends the need for security and resiliency. So security, cybersecurity, and privacy becomes a quite vital dimension in the software technology. And privacy by design actually really needs to be incorporated. And last but not least, also when thinking of the quantum compute, as we talked about, I think we need to understand that quantum computers are probably not something you will put on your desk and next to your laptop or desktop computer here, but quantum computers will be run mainly as data centers, in at least for a foreseeable future, which means that most of the applications which you are building as quantum computing is very efficient to some specific algorithms, but not necessary to all part of your applications. You will need to design software as a hybrid application in future, and quantum compute most likely will be consumed as a service based on those hybrid models. So there is a little bit of evolution, or not a little bit, quite substantial evolution also in the software layer, which needs to be taken forward over the next couple of years to get us successfully into the 2030s.
Jonna, did you want to add anything there?
Yes, I actually, thanks, Aaron. The thing is, what I wanted to add is really looking at also the impact of artificial intelligence in software development. So there are 2 layers to that. So of course, the artificial intelligence itself is written is software, and the development and evolution of different models, and and how we see models and how they become more energy efficient also is important. But then the other side is basically that also that how do you write software, and what is the impact and what is the role of artificial intelligence in that writing the software. And how do we see there is that we are now only in the beginning where we see that part of the code might be generated by artificial intelligence, especially by large language models. But we see that this is AI is coming in all areas of the software development lifecycle, in deployment, in testing, in upgrades, and so on. And there we're just now in the beginning, but these tools will be evolving over time into something that where really artificial intelligence with the human brain will be developing the software.
All right, well, now that we covered the hardware and the software, we can move over to the network evolution. So why don't you pick up from there, Stefan, and tell us a little bit about all these new digital services that are going to be added in the next decade.
Yeah, we had in Bell Labs Consulting, there was a traffic study been done, and where we were looking into a 10 years perspective on how do we see traffic overall going to evolve. Now, the interesting or the cases which have been looked into, we were looking into all of the different domains and also in the aggregate. So what we can say is around about that we will see roughly an increase in tenfold over the next decade in terms of the overall traffic growth or the traffic to appear, which means that there are some scenarios where we say, okay, this is a conservative scenario, this is aggressive scenario, disruptive scenario, but the difference is actually not that substantial. So even if there is a factor 2 or 2.5 difference in what we see, we can say roundabout. Let's assume for the worst case, so to say, or the best case, depending on the perspective, say we have a 10 times increase. This gives a good indication, or say, how do networks actually need to evolve in order to cope with the demand, right? So this is considering that on the mobile side, on the fixed side, we will need to cope for 10 times increase. Then we can have an understanding of what kind of technologies are really essential in the network evolution to cope with that.
10 times, that's pretty big. So you're going to have to make some big changes to keep up with that. Yone, how are these networks going to evolve to cope with all this new traffic demand?
How would I say this? The thing is, the networks will evolve in multiple, in multiple dimensions. There is one thing that where the networks need to change in their key capabilities is basically looking at the network, how it acts, how it works, and what we expect from that. So when we were talking earlier about the spatial compute, for instance, and new services which are basically based on that AI will understand what you're gesturing towards to the digital world and how you interact with the world around you. The thing is basically that means that you need to be connected the whole time. You cannot have blind spots anymore in your network. Mm-hmm. People won't tolerate that. So you need a lot more ubiquity. You also, that these traffic that Stefan was talking about, we're moving from a situation where we are passive users of traffic, so it's basically all downstream, to a world where the big part of the traffic will be also upstream, because we are now communicating with we're sending data much more towards the network because of the observations that we're doing about our environment and the world around us, and and some of that the processing of that data will be in the network. And so we see also then that the capability, the capacity needs to be much more symmetric than it has been before. And there are other things as well, which Stefan, for instance, already touched in the software area. Sustainability, of course, that is a part that is in the network as well. So when you look at these different network capabilities, and I went through just a few of them, is that basically that a network needs to be become quite different. And there, what you need to look at is that, okay, how do we bring the network to become then different? And what are the new technologies, where are the new approaches what we can do with the network?
And one of the things we mentioned here is the terrestrial networks and the non-terrestrial networks.
Yes, so good point. So the thing is basically what we're looking at here is that we're looking at how do we bring the network to the next generation? How do we bring it forward to meet these key capabilities? And there we have really things that we just make the network better. Basically, we evolve the network using more evolutionary technologies in the different domains of the network. But like you said, then there are other things which are basically more disrupting. They are newer. They basically allow the more of a quantum leap towards the future. Terrestrial and non-terrestrial network integration is a great example of that. But then looking at other things like also AI native networking, which is something that is coming now very quickly, and where Nokia has been working as one of the first companies for a long time. But then looking at technologies like quantum, how that impacts networking, and how the network itself changes, especially in the integration of sensing and communication.
Stefan, looking here at this slide, there's so many things that the new possibilities open up. They create other issues that need to be addressed, like, for example, the security and privacy focus over there. Quantum sort of changes the whole picture on that. Do you see how everything keeping up with all these developments? Do you see all the safeguards being in place for that?
Yeah, I think there are two of the technologies we talked about today quite a lot, so which means AI and quantum. They have a little bit of a twofold situation there. They are both addressing or creating actually additional security risks, but on the other side also they can help in order to make them networks and data more secure and better protected. So it's a question of using the technology for the right thing and helping to make it more safe, and basically looking for the evolution towards not only towards quantum safe communications and quantum safe data, and there are activities ongoing actually in order to enhance the cryptography in order to build that for a post-quantum environment.
But also for what they call Q-Day, right?
The Q-Day, exactly.
Yeah.
And there are and we have some and I think Michael will talk about that also in the quantum webinar, where we are give a rough estimation on latest view on where things go this direction and RSA could be cracked. But it's really something where we need to see that we have time currently to prepare for that, and Nokia has taken actually a big role in that and really protecting the environment, protecting networks and the data which is transmitted. Because we also need to see that if we foresee a future where we're going towards the clickable world, where the digital and the physical and the human world will connect into each other, communication becomes a critical infrastructure more than it is as of today, and therefore we are relying really on that, that it's properly been protected, and therefore it's also part of the DNA in which Nokia is building future networks.
Well, I guess that makes sense. So what you're saying with this focus on quantum, because in our tech vision, there's a subtitle there which calls a digital acceleration towards the quantum era. Can you talk about how all these elements that we're talking about, that we're going to have deep dives in AI, spatial computing, Web3, it also builds into this quantum era that we're talking about?
Yeah, well, the reason for the title was basically when we looked into the different technologies, and let's take them very specifically here. When we're looking into AI, looking into spatial computing, Web3, these are technologies which probably for the next 10 years will accelerate the digital transformation as where we have been into and will further give a push. In particular, AI is really seen as a boost, and people referring to that we are in the beginning of the internet or it feels like the beginning of the internet in the 90s, and now this will be accelerated and as a similar stage with AI. In other words, said for the next 10 years, those digital environments and the advancement in the digital technology will bring the three worlds together. The quantum era is kind of, and with quantum tech 2.0, so which means not only quantum compute, but as Jonna mentioned, quantum communication and quantum sensing, we will see some substantial disruption. And it's currently quite hard to describe on how the world then will really change. But it's clearly seen that due to this disruptive potential, there is a opportunity that a new era has been shaped, which with new paradigms, basically, built on quantum technologies. So it will be very interesting to see how this then really materializes. But for the next 10 years, it's rather about the acceleration of the digital transformation with the technologies which we mentioned.
Jonna, finally, the last sentence there, I guess, leads us to the last question. We need to keep up for the world to go forward. What exactly do you mean by that?
So Aaron, when we were discussing throughout this this time now about the new technologies, new futures, new services that are coming around, what we can really see, especially in the new services, is that these things are not possible without a network and within a good network and without an evolving network. And when we were talking about the network technologies and their evolution and disruptions that are happening. And we were talking about the key capabilities that need to be perfectioned in the network. What we basically say here is that the network need to keep on evolving. The network network technologies need to keep on going towards the future to ensure that the future that we're talking about can even happen. So therefore, the networks have to keep up with the expectations of the other technologies and the society as it changes.
Jonna, I mentioned a second ago, but integrated sensing and communication and all of the elements there of the new capabilities that'll give the network. This is a key issue in the 6G standardization discussion. So before we go to the questions, let's take a look at a short video that we have that describes what it is. Let's look at it now.
Senses are the way humans experience the world, and while they are powerful, they are limited to what we can perceive in our immediate vicinity. But what if we gave our networks the ability to sense, to become aware of our environments, the people and objects within it, to be our digital sixth sense? With this capability, we can map digital versions of the physical world, allowing us to interact beyond our immediate vicinity, extending our senses to every point the network touches.
We are at the ARENA 2036 Industrial Research Facility, where we have deployed our prototype system for joint communication and sensing. The signal is being sent out and it's being reflected, at least in parts, by the environment, including the robot itself. The reflected signal is being processed in the sensing processing unit, where we can obtain the distance, range, and reflective strength of the robot, which we then visualize in the radar view on the screen.
6G can give us the ability to fuse the human, physical, and digital world. And by expanding our awareness beyond our nearby surroundings, we are building a safer and more productive environment for all.
All right, we hope you enjoyed that video and that interesting presentation over there. And now it's time for us to go straight to the questions. So let's hop into it. The first one's for you, Jonna, and it regards the sustainability element that we were discussing earlier on. The question asked here is about the amount of power and water that it takes to make AI happen. And that's pretty large, and it's expected to get larger. So when we talk about climate goals, it's going to make it more difficult. How do you cope with the energy demand of AI in the future?
Yeah, that is a very good question, and that is something that, of course, the industry is working on. There are two parts to that. One of the things is clearly that there is this. We have to recognize that there is this problem that AI needs more energy, and we have to look at that what we use AI for, that we use it in a sustainable manner. The other thing is then that we have to make AI itself more sustainable. and we have to make it more energy efficient. We have to and we have to make it in a way that you can run things in a smaller scale than currently, and that is what is happening. The other thing about sustainability is, of course, to use AI to get towards the sustainability goals, and that is one of the things as well that we foresee, is that basically AI is used for that finding new ways of saving energy, finding new ways of creating more energy efficient approaches, but also ways of creating new energy generation. So making, for instance, solar more efficient, making the storing of energy more efficient, and doing that in a better way.
Okay, Stefan, let's go over to you. We got another question here about the technology itself and all the impact of the future that we're talking about. And we know that content's getting more personalized. So the question we have here from one of our viewers is, as the risk of the objective truth starting to disappear, people are getting pushed their own corners and they don't have any idea of what others are thinking. How do we deal with this new reality or non-reality even?
Right, privacy is a major concern there, and obviously there are technologies which are also evolving to address that, like differential privacy for AI, to ensure that the data and the models are been properly settled and disconnected from each other, so that there is mechanisms incorporated to make use of data, but without actually disclosing any of the private information there. But overall, it's a critical item, and also if you look for, we have a responsible AI program running, where we have identified the critical items of what to incorporate in order to responsibly make use of AI and responsibly deal with the data. And this is a key cornerstone of that. So it's a great research topic. It's a great topic also for implementation. And it depends on the companies actually to fulfill and to take care of this responsibility.
Johan, I'm going to hop right back to you because we just got a question come in this second specifically related to the last one, and I guess sustainability is a hot topic around here. So this one's the question is specifically about the emissions of the ICT sector, and we see that AI again is using more and more energy, but also device manufacturing is causing these huge emissions, and recycling does not seem to work great for ICT devices. That's what our comment is over here. How do you respond to that?
I mean, like there's no reason why we would say that there wouldn't be any challenges. Of course, in ICT sector there are a lot of challenges in terms of energy consumption and recycling and so on. Actually, this is something what we have said in maybe it didn't come very well out in this time, but what we've said as well, or when we speak about the technology vision, that we see also that there is more skepticism about the role of ICT in terms of helping with the climate change, because of exactly these things are giving ICT a bad rep. But these are just sound challenges that we have to work through. It's quite clear that we need solutions for that. I think that there is good consensus in the ICT industry that we need solutions for this, and that is what the different parts of ICT industry are working on as well. How long it will take for us to get there, let's see. But I think that there is good consensus that we try to solve that issue.
Stefan, I want to jump back to you about something we discussed in one of the earlier slides about specific technologies of terrestrial versus non-terrestrial networks. We have a specific question here about the impact of these new age satellite communications like Starlink, which has been in the news a lot. Could you talk about that a little bit?
Yeah, obviously we see a lot of activities currently ongoing with respect to non-terrestrial networks. Nokia also has been quite active in that space. We had demos at Mobile World Congress and currently live systems supporting some of our clients to build non-terrestrial networks. I think the key point here from a practical point of view when I talk to enterprise customers is actually the integration of TN and NTN. Because no one wants to manage multiple networks in their devices, say it in the automotive space also, or for logistics enterprises to take the management there. So the integration of that, in aligning and integrating terrestrial cellular networks with a non-terrestrial one and giving one subscription in order to make it seamless is one of the key criteria, and it depends on really the systems to be integrated. So there are better examples where this integration actually is something which is already on the roadmap. There are other systems which are more standalone, which probably have other application areas where they would make sense.
Yone, one of the slides that we had earlier was about highlighted digital acceleration towards the quantum era. We talked about that a lot, and that's one of the questions that we've had coming in right here. And the person asking it wants to know if we are already late in planning the upgrade to the quantum safe encryption, specifically in 5G core networks.
Yeah, so I think that the point is here that what we're saying is that there is no time to lose, and this is something that we should we have to start working on. And I'm understood in 5G there is already work ongoing. We, as Nokia, for instance, we have already some products in the fixed network side that are trying to achieve quantum safe. So it's high time to start working on this. I don't think that per se the industry would be late. I think that there is still time, but there is no time to lose now anymore, because if you think about the quantum safe encryption, it's not just about that what you can open up now, but it's also what you can store and you can open up later with quantum computers. So therefore, being early with quantum safe encryption and quantum safe cryptography is important.
Okay, Stefan, pop back to you here about the opportunities. We talked about AI a lot. There's a question here about RAN as well. The opportunities that are opening up for AI and RAN workloads on the same infrastructure. What can you tell us about that?
Interesting question, a very good question actually, because I think it's as part of the AI RAN Alliance, there are currently 3 streams been investigated, and sharing resources between AI and RAN on the same infrastructure is one of those. Additionally to using AI for RAN and using AI on RAN, so which means we are developing all 3 streams there, so looking on how to take benefit of AI for the radio access network itself, then how AI can take benefit of getting information from the RAN network, and the other one actually really where you have them as basically 2 applications running in parallel on the same infrastructure, sharing the hardware and the infrastructure part is the 3rd work stream. And I would invite the audience here to follow the activities of the AI RAN Alliance, and where also Nokia plays a vital role on defining the strategy forward.
Yona, we have a question here about automation, and we know that technology is becoming much more automated with repetitive and tasks throughout, and it's freeing humans to focus more on the creative, artistic, innovative work. We've written a lot about that, with the drive towards Industry 5.0. The question here is, how can we leverage the current and emerging technologies to support these higher level cognitive activities?
Yeah, so first of all, that what we said already previously is that when we look at the using AI in these automation things and automating things that have not been automated before, one of the important things there is really is the network, and starting already today, the networks are capable of supporting workloads and supporting the traffic that is needed by the early AI without any problems. And then we can start already by the deployed networks, we can get to a certain degree of readiness here. Then of course we're getting the basic technologies of AI and the fundamental technologies done. And I'm sure that with those technologies, we can automate already some of the things that we need to automate. And we are also getting, and most probably we can get out of more of the hardware and things like that we have today. Now, getting to the full potential and looking at that, then we have to, of course, work on the basics of the things. So getting the hardware better, getting learning to do the software more efficiently, and so on. And that we need to also then slowly upgrade also the networks to make sure that we have a basis for the we have the platform on which we can move the traffic. But the thing is, of course, when we talk about automation, especially when we talk about something like Industry 5.0, it's not only the challenge isn't only the technology. I'm like, we have already technology that we could actually automate or digitalize much more than we have. There is also a need in the change needed in the mindset, change needed in the how people do things, how the industries do things, and the interest and willingness to digitalize. So there we need to there needs to be some change as well.
Yona, we're running out of time. We have maybe good time for just one last question, if that's possible. If we can keep it to 2 minutes, let's give each one of you guys a minute just to respond, because it seems like this is something which has been repeating theme here about privacy. Stefan mentioned it before, because this verbal and sensor interaction, it can really have access to very personal behaviors and the feelings of individuals. How do we see privacy and data ownership evolving together? If each of you could just briefly address that.
Why don't you, Stefan, start, and I'll answer that.
Can you repeat that, please? What was
about privacy? You mentioned privacy before, and about how data ownership. How's that going to work? Those together.
Yeah. Again, as I said, I think it's a critical thing that we keep data separate from the models and the application where it's been used. So it's a question of separating that properly. Data privacy is one of the key criteria actually for any of the services to be successful. I mean, obviously people share quite a lot, but in order to make it, say in the case of spatial computing, to allow people to contribute to that, it also they need to be trusting in the entity, and they need to see that this is going to be their data has been managed in a proper way.
Yona, you've got 1 minute.
Yes, and I would build on that what Stefan just said. I think that like we said in the beginning when we were talking about the macro trends, the trustworthiness of the technology providers becomes more and more important in this world. And they're really, the thing is that to keep that trustworthiness, that technology providers also have to make sure that they don't break the trust of the users. When we go to this, really, that you have sensors that almost can read your feelings, there it becomes extremely important that people can trust that those things are not used against them. And that's where but on the other hand, because people stop using the technology if they stop trusting it, and or they don't even adopt the technology if they don't trust it. So there really that misusage of the information, that the technology providers don't misuse the data, that is extremely important for them as well.
All right. Well, thank you very much, Yona. Thank you, Stefan. It's been really interesting stuff, and we hope everybody who's joined us has enjoyed this session here. Please also spend a minute to provide us with some feedback for the session in a survey that will pop up with you in a moment, just when we're finished. You can also check out all the details of our tech vision on the Nokia dedicated webpage. That's nokia.com/innovation/technology-vision. Please tune in again in the coming weeks for Technology Vision deep dive webinars that we're going to have, and to learn more about Nokia's role in this vision. Be sure to register for the upcoming webinars. If you haven't done so already, you should be able to see it on your screen there. A reminder that there are 4 of them. AI, Web3, spatial computing, and quantum technologies. Is a QR code in your screen right now if you want to register for that. So I guess that does it this time. We hope you've enjoyed the introduction. Until next time, I'm Aaron Heller. Thanks to Yona and Stefan for kicking us off here, and we'll hopefully see you all again together on our next Nokia webinar.